functions. First of all, mappings. It would mean when we put the value of x, we will get the value of y. So basically, for this particular example, when we substitute x, it maps onto 2. When we substitute 2, it maps onto 3, and so on. The equation connecting these is x plus 1. And this is a one-to-one function because one value of x is giving one value of y. So one input gives us one output. Now, what one-to-one and many-to-one means? If you're talking about one-to-one, one value of x will give us one value of y no matter how many times we substitute it. Second is many-to-one. So we substituted, let's say, first value of x and got this value of y. And then we substituted second value of x and got the same value. So from many values to one. And the third one is one to many. Value of x is 1, but we are getting different values of y. So that is from 1 to many. And normally we do not consider the third one as a function.
So basically, many is x squared and it has two different values?
Yes.
Could it be more than 2?
It is more than 2, like this is being a quadratic function. If we'll be talking about cubic function, then again it is 1 to 1.
Wait, so there's 2 input and 1 output?
Yes.
But
in cubic it is not the case. It is the case in quadratic.
okay, so in quadratic, how is it 2 input and 1 output?
For example, we have y is equals to x square. So if I substitute x minus 2, I'm getting 4. Now I'm changing the input. That is 2. I'm still getting 4. The inputs are different. First it was minus 2, then it was 2. And the output is same. Many to 1.
Oh, I see. Okay.
As shown by the graph as well, that from different values of x, or let me say we just draw a horizontal line because it is also symmetric about 0. So at this point and at this point, these 2 points, it is giving same y.
Okay.
Determine whether each of the mappings is one-to-one or many-to-one or one-to-many. So first of all, we've just identified that one-to-one is linear. So let me just look at all the linear functions. The first one is linear, so that is 1 to 1. And this is 1 to 1. And when we see 12 over x, 12 over x, the graph looks like this. So with 1x, I'm getting only 1y. So that's again 1 to 1. There are more as well, like the cubic function we just discussed. This is the cubic function. It is again 1 to 1. Let me come in order. Number 2, what do you think it is?
So wait, for question 7 again. So it's 12 over x and it's 1 value of x and 2 values of y?
1 value of x and 1 value of y. See, 12 over x would look like this. It would look like just 1 over x. So 1 value of x gives 1 value of y.
Why would 12 over x be like facing each other?
Say y is equals to 12 over x. Now let me have some values of x and resulting some values of y. Let me say this is 1, then 2, then 3, then 4. So 12 by 1 is 12, 12 by 2 is 6, 12 by 3 is 4, 12 by 4 is 3. So at 1, y is 12. At 2, y is 6. At 3, y is 4. At 4, y is 3. So it keeps on decreasing. So you're getting this trend. Now on the other side, if I get x as -1, -2, -3, -4, so I'll be getting y as -12, -6, -4, -3. So at -1, it is -12. Then -2 is -6, -4, -3. So we're getting these values.
Okay.
This is also graphs of simple math sketching. So that is 1 to 1. If you draw like horizontal lines, it would cut at single point.
Okay.
Number 2, this is x square plus 5. So the sketch would look like this: x square plus 5 units above 0. This is many to 1. Different values of x would give same value of y. For example, we take these two values, one value of x and second value of x. This gives the same y. This is many to 1. Number 4 says graph of 2 raised to power x. Now when x is 0, it is 1. When x increases, the graph keeps on increasing. When x decreases, it keeps on decreasing but never touches. So this is again giving one value of y against one value of x. So 1 to 1. Sixth is x square plus 1. That is exact replica of question 2. Again, many to 1. Now, this is x is equals to, if we say y is equals to x, the graph would look like this. And if we say y is equals to minus x, graph looks like this. And we are talking about x greater than 0 only. So we remove these two and changing this response. I just took that as linear line. So y is equals to plus minus x. For one value of x, we are getting two values of y. This is one too many. For example, this value of x gives me two different y's.
Okay.
Okay. Defining a function is a rule that maps each x value just to one y value, x value just to one y value for a defined set of input values. This means that mapping either one to one or many to one are called functions when they are giving one value of y. So one to one was like this, and many to one was like this. The mappings x such that x plus 1, where x belongs to real numbers, is a one to one function. It can be written like this, these two things. When f of x is such that x plus 1 is read as a function, as I just said, such that x is mapped onto x plus 1. F of x represents the output values or the function. So when f of x equals x plus 1, f of 2 equals, we would just keep on substituting values of x. F of 2 equals 2 plus 3. 2 plus 1 is 3. The set of input functions is domain. These are the x values, and range is the y values. First worked example. The function is f of x equals 2x minus 1, where x belongs to R, is a real number. Minus 1 less than equal to x is less than equal to 3. I write down the domain of the function. So this is clearly domain is values of x, and we can see it starts from minus 1 and ends at 3. So remain is as it is. These are the values of x. And it says sketch the graph. I can see that the graph is a straight line at x 0, y is minus 1. So when we substitute x 0 got y minus 1, then when x is 1, 2 1 times 2, 2 minus 1 is 1 at x1, y is 1. So we would just draw the straight line. Now sketching and giving the extreme points for range. The first point is minus 1. 2 into minus 1 is minus 2. Minus 2 and minus 1 is minus 3. So at minus 1, it is giving minus 3. Either we write it like this or we write as given in the worked example or near the line with the coordinates. And then the extreme point is 3. 2, 3 times 6. 6 minus 1 is 5. So at 3, y is 5. Write down the range of the functions. So we can see the highest point is 5, the lowest point is minus 3. So minus 3 less than equal to f of x is less than equal to 5. Worked example 2. The function f is defined for f of x is equals to x minus 2 whole square plus 3. And for the domain 0 to 6. Values of x. Sketch the graph of the function and find the range of the function. So when we are looking at this, I can see that the turning point is x2 and y3. 1, 2, 1, 2, 3. X2, y3. Then we see that the coefficient of x square is positive. So it is a smiley face. When we draw this smiley face, turning point is right there, 2, 3, and we can find the point of intersection by substituting x is 0. So when x is 0, 2 square is 4, 4 plus 3 is 7. So this point of intersection is 0, 7. No intersection on the other side. And then the graph was from x is 0. So we should draw till 0 and not beyond that. And started from 0 and is moving all the way up till 6. So when we substitute 6, that is 6 minus 2 is 4, 4 square 16, 16 plus 3 is 19. So at 6, this is 19. Now range of f. The graph is in front, so there's no confusion. But sometimes student would just plug in this 0 and get 7 and then plug in this 6 and get 19 and quote this as range, which is actually wrong. Because we can see from the graph, it is quadratic, it has a turning point, and the lowest point in this case is 3. So 3 less than f of x is less than 19 is the range. Whereas this is not an issue in linear graph. We just substitute the lowest value of x and the highest value of x and we'll get the correct range.
So basically, it's from the lowest value to the highest. So that would be 3 and 19, right?
Yes, that is the spread in which the graph is present.
Okay.
Okay. Which of the mappings in exercise 1.1 are functions? So all the one-to-one and all many-to-one will labeled were functions, and one-to-many were not functions. Number two, find the range for each of these functions. Okay, range of functions. When I look at the first one, f of x is equals to x minus 5. So I just know that it is linear and it would look like this. So domain is given -2 to 7. So at -2, I'm checking at -2 is -7. So this is -2 comma -7. And the extreme end is f of 7. 7 minus 5 is 2. So at 7, this is 2. And it could be seen that it lies between these two values, which is -7 is less than equal to f of x is less than 2. Any doubt? The first graph x minus 5
Yeah,
for given domain lies between these two values.
-3 and 2.
Yeah.
Oh, we tried with -2 and negative and 7.
Yes. Because it was a straight line, so we just go for the endpoints. Similar way, f of x is equals to 3x plus 2. F of x is equals to 3x plus 2 is again a straight line. And it says the value of x are from 0 to 5. So no need to sketch before that. From x0, I can see this should look like this, positive gradient and positive intercept. So at x0, this is 2, and at x5, 0 done at x5, so 5 3 times 15 and 2 is 17. This point is 5 17. So for the given domain, for 0 less than equal to x is less than equal to 5, the range of the given function, the highest value is 17 and the lowest value is 2. So this
So
is
just
our final
plug
answer.
in, we just plug in the 0 and the 5, and then we get our range.
Yes, we were given with the domain, so we plug in the lowest and highest value to get the lowest and highest of the range of y,
So if
because
we
it
already
was a,
have, okay, so if
it
we
was
already
the,
have the highest and lowest, if
if
we,
we saw
yeah,
one more linear, try this C part and find the range.
one greater than or equal to x, greater than or equal to 9. I mean, no, one smaller than or equal to x, smaller than or equal to
It's,
9.
it's not 1. When you're substituting 4, that is not 1. That is -1.
Okay, so
So the
nine,
lowest value,
yeah.
you're getting the lowest value at -1, less than equal to 5 of x, and the highest value is by substituting -1, that was 9. So this is your range
Okay.
or the given domain. Now we are coming at D, and this is no more linear. F of x is equals to x square. So when the examiner says from minus 3 is less than equal to x from less than equal to 3,
That's just one value of x.
for minus 3 to 3, yes, if we substitute the extremes. But we know that if we draw this graph at minus 3, I'm going to get 9. At positive 3, I'm going to get 9. And at minus 2, this is 4. At minus 1, this is 1. At 0, this is 0. 1, 1, 2, 4, 3, 9. So basically, for these values of x, we can see that the lowest value of graph is 0 and the highest value of graph is 9. So the graph lies between these two values. This is the range.
Okay.
In this case, lowest and highest alone are not helping. We need to see where the turning point is.
Okay.
So 0 to 9 is the range. F of x is equals to 2 raised per x. Now, if we just remember the sketch, or else we could draw it again on spot by substituting few values. The domain is from minus 3 to 3. So we can see to right it is always rising and to left it is always falling but never touching the x-axis. So I can just substitute the extreme values. So 2 raised by minus 3, f of minus 3 is 1 over 2 cube, that's 1 by 8. On the other hand, substituting positive 3 is 2 raised by 3 giving me 8. So 1 over 8 is the lowest value at minus 3, and at positive 3 the highest value is 8. 1 by 3 is less than equal to f of x is less than equal to 8 for this given domain. One over x. Try this.
So first it's 1 over 1, and then it's 1 over 5.
Yes.
1 over 1 just gives us 1, and 1 over 5 is just 1 over 5. So then 1 over 5 greater than equal to x greater than equal to 1.
F of x.
F
When
of
we are about the range, that's f of x. That's right. The graph looks like this. So at 1 the value is 1, at 5 the value is 1 by 5. The function g is defined for g of x is equals to x square plus 2. For x is greater than equal to 0, write down the range of g. Now, two extremes are not given, but a range of x is given. So g of x is this function x square plus 2. If there is no limit, I would know that it should look like this. But the question is telling me that it is x is greater than equal to 0. So I don't need the other part. I could just erase it. This is how the graph should look like. So x is greater than equal to 0. We're drawing only this right hand side. And we know that at x0 is the lowest value. This is 2. So x0, y2. Therefore, for the given domain, the range would be g of x is greater than equal to 2. So we substitute any value of x within the given domain. We are getting y in this range. Okay. Number 4 says f of x is equals to x square minus 4. X square minus 4. Now x square is a smiley face and minus 4 gives the y-intercept at negative 4. And it says x belongs to real numbers. Like all the values to left, all the values to right, any value on the number line is value of x. So for all these values, we can see if we keep on substituting values of x to right, y will keep on rising. Values of left, x to left, it would keep rising. It could be seen from the graph and from the curve as well that the lowest value is minus 4. So f of x, the lowest value is minus 4, and to right and the other values, it just keeps on rising. So this is the range for the given particular domain. Graph spreads from minus 4 and upwards. We can write it like this, or we can write minus 4 is less than f of x is less than infinity. No need to actually write that because this is understood at minus 4 and above. Try question number 5, finding the range of f of x. Yeah, what is the range?
So we first start by making x 0, right?
No, we would look at the given domain because the range would differentiate according to the domain. And domain in this case is x is greater than equal to 1. X is greater than equal to 1. If I would just sketch, I can see the turning point is x1 and y5. So x1, y5, this is the turning point, and I can see it is a smiley face. This is the complete graph. But see, the domain limits from x1 and upwards. So we don't need this in this case. So it starts from x1 and moving on right hand side. This is my sketch. Now I need the range of this sketch. It's a coincidence that the turning point is x1, y5. It is at the turning point. So when we substitute x1, we are just getting f of x as 5. So the range is also f of x greater than 5. In this same question, if the examiner would have said that x is greater than equal to 2, so we would just substitute 2 because we know that the lowest point, the turning point as is at 1. We would substitute 2 and see 2 minus 1 is 1, 1 square 1, 1 plus 5 is 6. So we would say f of x is greater than equal to 6, despite knowing
So,
that if we complete this, it would be 5 onwards. But because we are restricted to 2, we're not looking to left hand side, we are just looking to right hand side. So this is x 2 and y 6
so
for
would
this
it
domain.
be impossible to find without like the limit of x is greater than or equal to 1?
Now that's quite possible, greater than equal to 1.
No, but if there was no greater than or equal to 1.
Like if it was not there,
Yes. So,
or like x belongs to r.
yeah,
Now
exactly.
that's again pretty much possible because we know that x minus 1 whole square plus 5 is a quadratic function, and the turning point is 1 comma 5. So 1 comma 5 is this point and it is a smiley face. So we know the lowest value is 5. So f of x would be greater than equal to 5. See, if I just sketch this, let me sketch this again. This is 1 comma 5. And the question was f of x is equals to x minus 1 squared plus 5. If it says x belongs to r, I would say f of x is greater than equal to 5. Any objection?
No, because all the values must be above 5.
Yeah. Now, if it says x is greater than 3, so that would mean this is x1, this is x2, this is x3. That would mean all the graph to left of it is discarded, and we are talking about the graph only on right hand side of 3. For that particular case, we substitute 3. 3 minus 1 is 2 square. 4 plus 5 is 9. We would say this is the range because we cannot come to left hand side of x, and I would use just this simple less than not equal to. If in the same scenario it says that x is greater than minus 2, what will be the range?
So we would put minus 2 as x, and then so minus 2 minus 1 minus 3, 9 plus 5, 14.
So
So,
you're saying we will have this as answer?
yes.
Now see, this is not the correct answer. See, if we substitute, this is minus 1, this is minus 2. At minus 2, at minus 2, I'm getting minus 2 comma 14, right?
Mm-hmm.
This is the value 14. But what does this say? This says the graph is x minus 2 and onwards. That means I can draw at minus 2, I can draw it 1, I can draw it 0, I can draw it positive 1, and then 2, and then 3, and so on. This is how the graph would look like because it says x is minus 2 and onwards. So minus 2 onwards, there's no limit to right hand side. But what is the lowest value? This is the lowest value, which occurs at 1, and the lowest value is 5. Within the given domain, the lowest value is 5.
Oh, so if it's below the turning point, then it would be still the same thing, but if it's above, then it would be different, basically.
Yes.
Okay.
So for quadratic, we always check if the turning point is within the domain or it is outside that. Number 6. The function f is defined for f of x is equals to 2x plus 1 whole square minus 5. Now, regardless of the domain, this is 2x plus 1 minus 5. I can see that the turning point 2x plus 1 equal to 0, x is equals to negative 1 by 2. So let's say this is negative 1 and this is negative 1 by 2. At negative 1 by 2, the value of y is minus 5. So the turning point is negative 1 by 2 and minus 5. And it is a smiley face. Now the domain was x is greater than equal to negative half. So if I'm going to respect the domain, it says x is greater than equal to negative half. That means we are only talking about this right hand side. Here x is equals to negative half. So for this, the range is this is the point which is actually the turning point. This is minus 5. So it would be minus 5 less than equal to f of x. What do you say?
Because it's below the turning point?
Yep.
Okay. But if, for example, x was smaller than negative 1 over 2.
Okay. If x was less than negative 1 by 2, that would mean that we are talking about this blue side.
Mm-hmm.
In that case, the lowest value of the function is minus 5. And this is the range. Now change.
Okay.
Change the value of x if you want to clear up. Same question, different value of x. Right?
So if it was instead of minus 1 over 2, if it was 1.
Okay, if it is x is greater than equal to 1. Now I see the graph is right in front of me and 1 would be to right of it, to right of the turning point. So
Mm-hmm.
if I substitute 1 there, that is 2, 1 times 2 plus 1, 3, 3 square is 9, 9 minus 5 is 4. So at 1, I am getting 4. So I would say 4 is less than equal to f of x, or f of x is more than 4. Basically, if we are limited with x is greater than equal to 1 and we need to sketch that, we would start our graph from this point because x is 1 and more, 2, 3, and at 1, we're getting y is 4 and it keeps on rising to right. Whereas the turning point was somewhere else. Whereas the turning point was at x minus 1 and y minus 5. But we are least bothered because we have to follow our given domain. This was the complete graph, but we are rejecting this and we are moving from x onwards.
So if it was x is smaller than 1, it would still be the same?
In the same question, in the same case, if it says x is less than equal to 1, see particularly x less than equal to 1 is this red region now,
Mm-hmm.
and the lowest value is at minus 5. So it
Oh,
would be
it's minus 5. Okay.
because from if we just draw it from 1 and below, this is 1, the graph is going to look like this, and the spread is from minus 5 upwards.
Okay.
Try number 7.
6 greater than or equal to x greater than or equal to 9.
Um, I would disagree slightly. See, this is f of x. Whenever you answer this, first ensure is the turning point within your domain. See, the domain is 2 to 7. 2 is less than equal to x is less than equal to 7. So before I answer that, I am going to confirm if my turning point lies within my domain. And just looking at the graph, I can say the turning point is 3, comma 10. So turning point is at x3, which lies, yes, it lies there. So at x3, y is 10. This is x1, this is x2, this is x3, and that's 10. 3 comma 10 is the turning point. Second thing we notice is it is a sad face negative x square. So when x is 0, I'm getting 3 square is 9, I'm getting y as 1. So at x 0, y is 1. Without any limits, the graph will look like this. And when we have limits, like we can draw only from 2 to 7. So at x2, this is 2 minus 3 is minus 1 square 1. 10 minus 1 is 9. This is 9. So if we can just draw the graph from 2 onwards, this is how it would look like. So at 2, no doubt at 2 it is 9. And at 7, 7 minus 3 is 4. 4 square 16, that is minus 6. But this is not the range. From minus 6 to 9 is not the range, because for the given domain from 2, 3, 4, 5, 6, 7, the graph goes till 10 and comes back again. For these values of x, the graph ranges from 10 to the lowest point minus 6. So
Also,
basically,
this
x
10.
is less than 10 and greater than minus 6.
Okay, so that has to be below. Has to
Yeah,
be above that range. Okay.
for these values, turning point is within these values, and that is the highest point in this case. If I would summarize, this is my graph. Let's say this is x2 and this is y3. So if I have a is less than equal to x is less than equal to b, If A and B looks like this, like the turning point is actually out of them. The turning point is out of them. So no need to check the turning point. I will just check what is the value of y at A. Let's say this is C and let's say this is D. So I would say C is less than equal to f of x is less than equal to D.
Mm-hmm.
If I have it on the other side, like say E and F, and at E and F I have X and Y. So when X was F is less than equal to X is less than equal to E, I would just say that it is from C, sorry, that was XY, X less than equal to F of X less than equal to Y, because the turning point does not lie between these. Turning point is not between these. Okay.
Okay.
So if it would say that the graph looks like this, the turning point is x2, y3, and examiner says that from A to B, at A I'm getting this as x, at B I'm getting this as y. But see, from A to B, the lowest value is 3 and the highest value is y. Let me change that for now. Lowest value is 3 and highest value is q.
From A to B,
From between A to B.
between A to B. Lowest value is 3 because, yeah. And then, okay, highest is up to B. So that'd be A. Okay.
Always check if the turning point is there. We would answer that.
Okay.
So if I say f of x is equals to x square from minus 3, minus 3 is less than equal to x is less than equal to 7. And I'm asking for the range. Now, if this student is not checking the turning point, he would jump for the lowest value, the lowest domain, substitute it and get 9, and substitute the other extreme and get 49. Now, if they're not checking, they would say minus 9 is less than equal to f of x, plus 9 is less than equal to f of x is less than 49, right? But if we just sketch the graph at minus 3, and this is 1, 2, 3, 4, 5, 6, 7. At minus 3, we were getting 9. At 7, we were getting 49. But see, the turning point is between these two, and that is at 0. So the range for this particular graph for the given domain would be actually 0 is less than equal to f of x and is less than 49. See, at minus 3, this is 9, 4, 1, 0, 1, 4, 9, 16, 25, 36, 49. So the lowest value attached was 0 within the given domain. We always check for turning point first.
Okay.
And one question is left. Try that in homework, and we'll start composite functions.
Okay.
You have this same book.
I have this.
Maybe the book is different, but the questions are. Same.
No, not the same, but they can just do it on that.
Okay. Composite functions. Most functions that you meet are combination of two or more functions. For example, the function x is 2x plus 5. You remember in simple math, we substituting those functions.
Yeah.
That is composite function. So we can cut the basics and jump to the question. So first worked example, f of x is given x minus 2 whole square minus 3. Then g of x is given 2x plus 3 over x minus 2. And it says find fg7. If this 7 was not given, I would have to substitute the complete function g in f like this, 2x plus 6 over x minus 2 minus 2 squared minus 3. So the x is completely replaced with g. But luckily, the numbers are given. When numbers are there, it would simplify to smaller fractions. So we would just simplify and get f of g of 7 first. That is 2 into 7 plus 6 over 7 minus 2. So that's 14 plus 6 is 20 by 5, and it is 4. So basically we are substituting 4 in f of x because g of 7 is equals to 4. So when g of 7 is 4, we just substitute 4 now, and 4 goes here as 4 minus 2 is 2. 2 square is 4 again. 4 minus 3 is 1. So for this composite function, when x is 7, fg7 is 1. F of x given, g of x given, find fgx, gfx, ff. Now in this case, numbers are not there, so we would just simplify. Let's do and compare the answers.
F squared x?
Yeah, f square means we are substituting f in f.
Oh, okay.
So first one was fgx, so we are substituting g in f, where this is f and g is x square plus 5. Simplifying, 2x square plus 10 minus 1 is 2x square plus 9. Let us just finish and then compare. Just compare 2x square plus 9. Second says gfx. So x square plus 5. This is g and f being substituted. So that's a square minus 2ab plus b square plus 5 simplifies to 4x square minus 4 plus 6. 4x plus 6. And the third one is f square x is basically fx. So 2 bracket 2x minus 1 minus 1. 4x minus 2 minus 1. 4x minus 3. 4x minus 8. So these are composite functions. Every other thing would remain same what we've done in the first exercise, range, domain. The concepts are same. G of x is given. Find fg2. Try this. Whenever there are numbers, always simplify it first and then substitute.
Okay. So we first simplified g of 2. So 4 minus 1, 3. So we have to put 3 into f. So 6 plus 3. So that's 9.
Correct. Number 2.
51.
Correct. Now number 3 says ff3. So first we substitute 3. 3 plus 2 is 5 square is 25 minus 1 is 24. Now we're substituting 24 again. So 24 plus 2 is 26. Using calculator, 26 square minus 1 is 675. This exercise is simple. The function f is defined by f of x is equals to 1 plus square root x minus 2 for x is greater than equal to 2. Now the domain is defined because we cannot have negative value in the square root. And g of x is 10 over x minus 1 and x is defined as greater than 0 because we cannot have denominator as 0. So finding g f18, so first we substitute 18 in f. 18 minus 2 is 16, square root 16 is 4, 4 plus 1 is 5. So we substitute 5 in g of x. 10 by 5 is 2, 2 minus 1 is 1. So g f18 is 1. Okay, try number 5.
67.
Correct. Okay, h of x is given x plus 2 for x greater than 0. K of x is given square root x for x greater than 0. Express each of the following in terms of h and k. Now see, square root x plus 2 is given. Now I see that if I substitute k in h, like if I write this hkx, then I can get this. If I just substitute this k over there, that will be square root x plus 2. So the first one is hkx. And when we look at the second one, this is under the root. Under the root is x plus 2, and x plus 2 is h. So we are substituting h of x and k. Any doubt?
No.
Number 7. The function f is defined by f of x is such that 3x plus 1, x belongs to R, real number. The function g of x is x belongs, g of x such that 10 over 2 minus x, where x is not equal to 2 and it could be any other value because at 2 the denominator would be 0. Solve the equation fx5. It's simple again. fx5, we are going to substitute f in g. We have that writing space. So we are substituting f in g, and g was 10 over 2 in place of it with 5. 10 over 2 minus, where f of x was 3x plus 1, making use of brackets. 10 over 2 minus 3 minus 1 minus 3x minus 1 equals 5. 10 over 2 minus 1 is 1 minus 3x is equals to 5. Cross multiply is 5 minus 15x. This is 5 is equals to negative 15x. So x is equals to 5 over negative 15. X equals negative 1 by 3. Question number 8.
So that would be x equals 4 and x equals negative 2 over 3.
Correct. Okay. Question 9 is same theme. Substitute and solve. Number 10, x given, g given, substitute and solve. Just the difficulty level is increasing as these are more fractions. Number 11, we substitute. Let's try this. X is in denominator and that's squared. Okay, 11 says f of x is given, g of x is given, and we are substituting g and f, making it 10 over x plus 4 whole squared plus 3 is equals to 39. Oh, I was just foreseeing that maybe I'll have to open it with a plus b whole square, but just
No,
after
yeah.
this,
For both sides, and it'll be 6 equals
yeah,
plus 4x.
so that's 36 and square root both sides is 10 over x plus 4 equals 6 and 10 over x plus 4 equals minus 6.
If it was plus 4, let's say, and we moved it to the other side, then we would open the fraction. So that would be 10 plus 4x over x.
Sorry, what change are you expecting?
So if it was instead of plus 3, it was plus 4, and we moved it to the 39.
Okay, so that we square root 35 then, and we'll get answer in decimals.
Oh, so we still square it. Okay.
Yes, same thing. Because of this square,
Okay.
we're doing that square root. we'll be getting that in either we will would just keep it like square root 35. We would have done it this way. 10 over x is equals to square root 35 minus 4, and then take the reciprocal and take 10 on the other side. 1 over square root 35 minus 4, and then that's 10. So, and then go for rationalizing or something else. That depends on the demand of the question. If it says two decimal place or keep it in exact form, but the process stays the same.
Okay.
10 over x is equals to 6 minus 4 is 2. So we cross multiply, x is equals to 5. And 10 over x is equals to minus 10. Cross multiply, and x is equals to minus 1. The function g of x is defined for this, and let's try this 13th number. 12 is again same. The function f of x is defined for f of x is equals to x cube, g of x is equals to x minus 1. F of x is x cube, g of x is x minus 1. Express each of the following as a composite function using f, only f, or g, or both. Okay. So a part is x minus 1 cube. What do you think is the composite function responsible for this?
So then that just has to be G into F.
Correct. So I would write fg. B part, x cube minus 1.
Would be G into F.
F into g.
F into G.
C part, x minus 2. One thing, if you're looking at x minus 2, clearly f is absent. What
Mm-hmm.
you would,
So
so this,
G.
so g into g, because only g will not give us minus 2. And let's check. We can definitely do the rough working in exam as well. This is g of x, and if I substitute g into this, that is going to be g of x minus 1, and replacing g of x is x minus 1, giving me x minus 2. So for sure this is g of x, which could also be written as g square x. And then d part is
So that'd be F squared X.
correct. Uh, no, cube.
And
Cf of x is x cube already.
mm-hmm.
So squaring would give x 6. If we just square, that would give
Oh,
x 6.
okay. Okay.
This is a x cube. Okay. So we've just covered two exercises, simple functions, one to one, one to many, many to one. And then we've discussed domain and range. Apart from that, composite functions and modulus functions. The rules are going to be same. In your free time, just try few questions which are left for practice, and you can also come to this exercise. Modulus function only would mean whatever we studied in chapter 5 actually,
Okay.
and everything else The all other concepts would stay same.
Okay.
So indirectly, we've already covered exercise 1.4. So you can just practice few questions from here, and I guess we might need few points to discuss for this question for simultaneous equations. Or still, I just remember that we did those as well, drawing the two functions.
Mm-hmm.
Either we just substitute and it will convert into that equation. For example, the first one is x square minus 16 is equals to x plus 4. So one's with positive, one's with negative. Or either we could just sketch, let's say solve each of the following pair simultaneously, no sketching. So this is somehow covered in more than 90%. And then these are
Okay.
curves. I guess we did these as well.
Yeah.
So keep moving forward till the point you feel you know, and just keep practicing few questions.
Okay.
All few, skip few. This is exactly something we've already done. So we will be able to save time and cover more. Inverse function, as in simple math, but only the difficulty level would slightly be more. And we'll definitely discuss these inverse function and the role of turning point.
So I'll do some questions.